Today my topic is about region of integration. Okay, so here the problem. Then evaluate double integral of region of y dx dy, where R is the region bounded by the parabolas y square is equal to 4x and x square is equal to 4y. So at first writing given parabolas. So the given parabolas are y square is equal to 4x and x square is equal to 4y. So now the diagram corresponding to the given parabolas, both parabolas are passing through the origin only. So see here, it is the parabola of y square is equal to 4x and the next parabola is x square is equal to 4y. So here the question was given like that, R is the region bounded by the parabolas, this area. So bounded area means this area, students. This area we are going to evaluate region. This area. Okay. This is the question. So evaluate double integration of y dy dx, y dx dy or dy dx, where the region is bounded by the two parabolas. The two parabolas are x square is equal to 4y and y square is equal to 4x. So bounded region between 2 points here, that is O and A, or A and B. So of course here in O point it is the origin point, that is 0, 0. Now we have to evaluate A point here. So at this point two parabolas are intersecting here. So then to get the point value A, solving y square is equal to 4x and x square is equal to 4y. Solving both parabolas here to get the value of A. So y square is equal to 4x, and by using this parabola the value of y is x square by 4 here, and substitute this value in this y square is equal to 4x. So y value is x square by 4, then x square by 4 whole square is equal to 4x, then x power 4 by 16 is equal to 4x. Okay, and then x power 4 is equal to 4 into 16, that is 64x. 1x will be cancelled, then x cubed is equal to 64 and x cubed is equal to 4 cubed, then the value of x is 4 here. Okay students, and substitute x value in any one of the parabola equation. Substituting x value in any one of the parabola, I am substituting in y square is equal to 4x parabola, then y square is equal to 4 into 4 and y square is equal to 16, y is equal to 4. Okay, so though the value of x is equal to 4 and y is nothing but 4. So here the intersecting point is 4, 4. Yeah, y square is equal to 16, students. One doubt will be rises in your mind, that is, if y square is equal to 16, why can't we choose plus or minus 4 here? Of course the value is plus or minus 4 only, but the required region is in the first quadrant. Then in the first quadrant all values are positive only, that's why we are taking only positive value of y here. Okay, then the intersecting point A is 4, 4 and the intersecting point of origin is 0, 0 and it is the required region here. Yeah, now finding the problem here. So the evaluate region is y dx dy. To evaluate this y dx dy, we need the limits here. Okay, so according to the double integration evaluation procedure of a double integration, to do the double integration, students, one limit is in terms of variables and another limit is in terms of constants only. If y is in terms of x, x is in terms of constants. Then if x function is as in function of y, then y function is in terms of constants only. So now writing the y limits are, so how to find out the y limits here? Students, here observe, this is the required region. this is the required region. So in required region, observe the two parabolas, x square is equal to 4y and y square is equal to 4x. So the y limits as x square by 4 to 2 root x. How you will get these roots here, students? See, this one is our required region, okay, and this parabola is nothing but x square is equal to 4y, and this parabola is nothing but y square is equal to 4x. This is our required region, okay. In required region, the lower part of the required region for the parabola x square is equal to 4y, and upper part of the required region, the parabola y square is equal to 4x. Then this parabola limits becomes as a lower limit, and this parabola limits becomes as a upper limit. So if you want to change y limits in terms of x here, then y is x square by 4, and here y square is equal to 4x, then y is nothing but here, y is root of 4x here. Then if y is root of 4x, then the value of y is nothing but here root 2x only. Okay, students. So if y square is equal to 4x, then y is equal to 2 root x only. That's why this limits x square by 4 becomes as a lower limit, and 2 root x becomes as a upper limit, and x limits are 0 to 4 according to the diagram. X limits are 0 to 4. Students, one thing you have to listen here carefully. It's not compulsory. Then you have to change y limits as in the functions of x, and x limits as a constant. You may change as x limits as a functions of y, and y limits in as a functions of or y limits as a constant. That is your choice. Y as x, x constant, x as y, y as constants. Okay. Okay, now I am writing the limits for the question. Y is equal to x square by 4 to 2 root x, and x is equal to 0 to 4, and y. So first we are doing with respect to y integration, and y dy, and next dx. Okay. So now doing the corresponding integration of the function, that is y here. Okay. Yeah, y integration is, we know that it is y square by 2, then integral x is equal to 0 to 4. Y integration is y square by 2. Lower limit is x square by 4, upper limit is 2 root x dx. So at first 1 by 2 common, x is equal to 0 to 4, y square, x square by 4 to 2 root x. Okay. Then 1 by 2 integral x is equal to 0 to 4. Substitute the limits. 2 root x whole square minus x square by 4 whole square. We are substituting limits only for y only, students. Then y square becomes as a here the value of 2 root x whole square here. Okay. So now doing the simplification is equal to 1 by 2 integral x is equal to 0 to 4. 2 square is 4, and root and x will be cancelled. X minus x power 4 by 16 into dx. So now doing the integration with respect to x here. 4, and for x integration is x square by 2, and 1 by 16 x power 4 integration is x power 5 by 5, 0 to 4. Substitute the limit, students. 1 by 2 and 2, and here 2 into 4 square minus 1 by 16 into 4 power 5 by 5. Then 1 by 2, 16 into 2, that is 32, minus 4 power 5 by 16 into 5. Then finally you will get the answer of this term as a 9.6. Okay, this is the answer of this question. Yeah, the one more question about this region of integration. Yeah, the second question. Evaluate double integral or x square plus y square dx dy in the positive octant for which x plus y less than or equal to 1. Okay, the region was given here. So region was in the positive octant for which x plus y is less than or equal to 1 was given here. Yeah, the given integral. So given integral is x square plus y square dx dy. Okay, and the region was given here. That region is in the positive octant for which x plus y less than or equal to 1 only here. Yeah, for x plus y less than or equal to 1, then x plus y is equal to 1 and y is equal to 1 minus x here. Yeah, drawing the diagram corresponding to the region. So yeah, x plus y is equal to 1 is this line. X plus y is equal to 1. So here x plus y is equal to 1, students. So if you want to know how you will get this diagram, so you may draw like this. You know very well about this procedure. Okay, if x plus y, then y is 1 minus x. If x is 0, y is 1. If x is 1, y is 0. If x is 2, y is minus 1. If x is 3, y is minus 2. If x is 4, y is minus 3. Then you may plot these points, then you will get the diagram like this. X plus y is equal to 1. Okay, and this is the origin, and this is A point, and this one is B point. So A point is on x-axis. On x-axis the value of y is 0. B point is on y-axis. On y-axis the value of x is 0. See here, to get the point value A here, so on A point on x-axis the value of y is 0. Then we need to on x-axis the value of y is 0. We need to find out the value of x here. So how we can find out? See here, this point is intersecting x-axis and the line. So x-axis and the line is x plus y is equal to 1. So we know that the value of y is 0 here. Then substitute the value of y 0. Then you will get the value of x as a 1 here. Okay, and here also this point, the B point, you will get by intersecting y axis at the same time the line, that is x plus y is equal to 1. So on y axis the value of x is 0. Substitute the value of x is 0, then you will get the value of y as a 1 here. Then these are the points here. Okay, A point is 1 comma 0 and B point is 0 comma 1 and origin point is 0 comma 0. So now the required region is this thing, this region, required region. Okay, students, this region we are going to evaluate. Yeah, for that purpose we need the limits here. Y limits are 0 to 1 minus x. So how you will get 0 to 1 minus x means here in the question it was given that the region is in the first positive octant only. Then positive octant means all values should be in positive only. Then here in this region students, the value of y starts from 0 here. See here in this point 0 comma 0 here. So y starts from 0 to, according to the double integration evaluation procedure, y limits are in terms of x. Then y limits have to taken as a functions of x here. Then according to the given x plus y is equal to 1, so y limits becomes as a 1 minus x. That's why the y limits are 0 to 1 minus x. And x limits are 0 to 1. According to diagram, x limits are here 0 is there and here 1 is there. So, okay. So then now doing the integration. Double integral or x square plus y square dx dy is equal to. So at first writing y limits 0 to 1 minus x and then x limit 0 to 1. The integrand function x square plus y square. At first doing with respect to y and then doing with respect to x. Why students here we are doing with respect to y at first? Because y limits are as a function of x here. X limits are in the function of constants here. So that's why we are doing integration with respect to x at first, y at first. Okay. So now I am doing the integration. Yeah, the function is x square plus y square. I am writing that function. The function is x square plus y square and then dy. Yeah, okay. Integral x is equal to 0 to 1. Students, here x square is there. Okay. So x square as a common. Integral y is equal to 0 to 1 minus x 1 dy and integral y is equal to 0 to 1 minus x y square dy and into dx. Okay students. So because we are doing integration with respect to y, then x square as a common here. Okay. Is equal to integral x is equal to 0 to 1 x square. So 1 dy is y, that is 0 to 1 minus x, and y square integration is y cubed by 3 0 to 1 minus x and dx. Integral x is equal to 0 to 1 x square into 1 minus x and plus 1 by 3 into 1 minus x whole cubed dx. Okay, now doing the integration with respect to x. Before doing the integration, so do the multiplication with x square here. X square minus x cubed and plus 1 by 3 1 minus x whole cubed dx. So now divide the individual integrand term here. Then integral x is equal to 0 to 1 x square dx and minus x is equal to 0 to 1 x cubed dx and plus 1 by 3 integral x is equal to 0 to 1 1 minus x whole cubed dx. Yeah, x square integration x cubed by 3 0 to 1 x cubed integration x power 4 by 4 0 to 1 and plus 1 by 3 into 1 by x whole cubed integration 1 by x whole power 4 by minus 4, because here minus x is there, then differentiation of x becomes as a minus 1 while you are writing the denominator value here. So now x cubed by 3 within the limits 0 to 1, x power 4 by 4 within the limits 0 to 1, and minus here 1 by 3 into 1 by minus 4 is as minus 1 by 12, 1 minus x whole power 4, 0 to 1 limits. Okay, substituting the limits, upper limit minus 1 by 3 and minus 1 by 4 and minus 1 by 12. Yeah, for upper limit is 1, then 1 minus 1 becomes as a 0, and minus for lower limit, that is 1 minus 0 becomes as a 1 here. Yeah, so it is equal to 1 by 3 minus 1 by 4 and again plus 1 by 12, because here one minus is there, this one, and again here one minus, then minus into minus as a plus here, then 1 by 3 minus 1 by 4 and plus 12, LCM is 12, so and 4 minus 3 plus 1, that means 4 minus 3 1 and 1 plus 1 2, 2 by 6 12, then doing the cancellation, final answer is 1 by 6. Yeah, thank you students. Please like, share, subscribe Easy BTech channel.